All right, for anyone playing along at home, there we go. We mainly need graph paper because we're going to practice solving equations today and practice graphing them. Here's our answers for 521, though. 18/7 is a better, more accurate answer, but I know lots of us like decimals. So like 2.57 would be your decimal approximation, and then about 19.4 minutes. We will go over the back here in a second. Any questions from the front? You have what? I have no idea. Probably. That's normally when the gym cycle changes. Yeah, this thing doesn't have a date on it, but I would guess. Aiden. Yeah, I mean, if you drop a straight line down from their intersection point, it looks like it's pretty much at 2 o'clock. So because we're talking about distance, when Leslie's line is beneath Gail's line, that means Leslie's behind, right? So Gail's in the lead because he's gone a further distance. But then right here, Gail is taking a break, right? Kind of like tortoise and the hare sort of thing. So then Leslie crosses. Sorry, and this is the version that Robert thought was his homework. And like this question's not super difficult, even if you were a Math 7 person. They just haven't talked about graphs yet. So they would have a bit harder of a time than you. I think it pretty much drops down to 2 o'clock for part B. So that was probably just a mistake from like you working fast or whatever. Any other questions on 28?
Oh, does D really matter what we said?
Yeah, I mean, they tell you how long the race is, right? So, I mean, even, I keep picking on Robert, but that's why there's markings on this paper. Robert solved this. D? Oh, I'm talking about E. What do you think happened to Gail between 1:30 and 3? Yeah, what do you mean, does it matter? What's your answer there?
I said got hurt or went to a snack.
Sure, yeah, that's why I like looking at your guys' homework. But either way, he wasn't running. Right? So whatever, I mean, if I'm running a race, I bet I'd probably had to go to the bathroom at some point. Like, yeah, I'm probably Gail, who went to the bathroom, got a snack. Went to the bathroom, got a snack, took a nap, and then decided I'll run again. And, you know, Leslie passed me and, like, you know, yeah.
And you spit up and passed it to her.
Well, yeah, but here I might get a cramp. Yeah, especially because I'm not running 60 miles. Yeah, that would be impossible. All right, so on the back, especially because we went out of order, 29 asked us to find these rules, which we're still developing our skills with that. Guys, this comes down to, like, your brain. Like, it's not who is smarter. It's just how your brain is kind of wired of how easily or not you can see these things. Get out of here. I don't know why your thing popped up. There we go. So remember that to find the slope value, we're always looking for the change in y over the change in x. So I can relate any points I want, but I like looking for nice ones. Like here, 8 to 9. So that's a +1 for my x, so I know that my denominator would be a 1. And it's a +3 for my y, so I know that my slope is 3. So that starts to build. I know that y is 3x because that change is what gets multiplied by the x. The problem is, then I need to add on what my y-intercept is, which if it's negative, especially, I would need parentheses. If it's positive, I don't really need parentheses. But who can tell me how to work from this point and figure out what your y-intercept would be? Jake? And actually, this is why I gave you guys graph space. Did you use your graph that I could actually show it to people? Or
I use my graph, but also I can say an equation too.
Did you graph these? That's look. I asked him because I didn't want to put it like his paper under here if he wasn't done. Yes, you're supposed to graph it. I just didn't want to take the time to build one from the beginning.
It's not very good.
Ooh, I'm a little concerned that you switched around your X and your Y. So I appreciate you having the confidence to give us your paper. But I'm a little... Wait, maybe. No? I think the problem just is you didn't scale this far enough for us to see the points that they gave. So 2, 5, that's a point we got, and Jake's got that point. So actually, no, I think we're good. This is our x-axis. This is our y-axis. I would prefer them to be a tad bit bolder, so I can tell where the x-axis actually is. I'm guessing it's right here, but I'm guessing.
I had the zeros around.
So then you want to talk through how we got back to our y-intercept? You knew the slope was...
times 3.
And then you put this point...
Yeah, and then we... 2 times 3 is 6, and you minus... Yeah, add a negative 1.
So we can work the slope backwards, right? If our slope is positive 3, we know that means go up 3, go right 1. But if I put that point 2, 5 on the graph and work backwards from there... You with me, Max? Just checking, because... You're looking down, not up. Huh? So if we work it backwards, that's how we get back to our y-intercept. Thank you.
I just realized I need to do 5, 2, 2. And while I'm doing it, I was like, oh god, I'm not going to get this done. This is less moderately hard as others have been.
Less moderately hard. Maybe it's because we're like starting to get some mastery about these skills.
Especially 539.
That's good news.
That was very simpler.
522.
That was very... On 522, yeah, 539. That was very easy.
The simplicity level was that.
But can we look on 522, can we look at a B of 540?
Let's start on the front. So 522. If you graphed and figured out your science and math clubs, right? So remember, the growth is what gets multiplied by your x.
Can you go back? I didn't see 531. I just 531.
Here's 531. Here I got to scooch over to see. 531. Any questions on that? Guys, on the homework I'm about to give you, there are literally answers on the back of it. I made it kind of fun, like where you have to flip your page upside down to read the answers. But like, I don't care if I put the answers in front of you, right? That's like, I don't care. All our answers used to be in the back of the textbook, well, the odd numbered answers. What I care about is that the process makes sense. So I don't even care if you get a wrong answer. That's actually a good thing, as long as you can figure out your mistake. So does anyone need me to go over 31? I would be happy to do it, but I want you to try to find your own mistake first.
Yes. I said any real number for every single one.
Then we might need to work together, but I will solve at least one of them for you, and then I think you might have that like, oh.
Negative, what am I negative with positive?
Yes. So, C is probably more difficult. So let's go ahead and do C. I'll skip over A for the time being.
Probably less moderate.
Less moderate. So, first off, what some people get confused about is this. This is our equation. We're solving it for M, meaning at the end, we want M equals. That's what it means to solve for M. So the only M I see is over here. So I need to start isolating it. To start isolating it, I want to get rid of this minus 6. So what do? Add 6. And of course, we all use a bunch of colors while we're doing our work, right? No. But if you want to start doing it, it seriously helps your brain. Seriously helps your brain to be able to see what we're doing. Then, because I have 2M, but I only want 1M, what do? And everything gets divided by 2. So you can either write it as one wide division or split it up. But we then get 2n plus 5. Does it make sense how you probably just were not actually doing what they asked us to do?
I think I was there's a lesson for that, and so we go over doing math. Like I can do math lunch. So we can go
Sure. I mean, so it's all inverse operations. Yes, you are always welcome at math lunch. Anybody's welcome at math lunch. But the biggest thing is inverse operations. So here, Like we would add 5 on both sides, then divide by 2. Right? Here, to get w by itself, we subtract 9 on both sides, then divide by -3. And this is where I believe Colin was just double checking about, wait, a negative divided by a negative. Because if we subtract 9 from both sides, this becomes p minus 9. Guys, again, I will do your work for you. I don't care. I just want to make sure you understand stuff. Divide by -3 to get the w by itself, because now this becomes your favorite thing, the giant one. So I'm going to draw this one as one big division, but it divides by both. So w will now be, I'm going to bump it over here to write it, because I kind of ran out of space. -9 divided by -3 is +3. P divided by -3, though, is -1/3 p, or you could just write -p over 3 or p over -3. There are various ways to write it, but this puts it kind of in like what looks like slope-intercept form, right? If I put the fraction in front and then the integer value, it's kind of like slope-intercept form. Other questions from 2-1? Yeah. So I got to get some coworkers to double check on that stuff. That just when people jump the line, that they're actually coming to math lunch. Hey, so Connor didn't call anybody out specifically. He's just making me aware of a thing and making people aware. If you say you're coming to math lunch, you have to actually come to math lunch. You can't hop the line and then be like, oh, wait, I've decided I don't need to go. That is unacceptable. That will get you lunch in the office. I'll just say it right now. Yes. Yeah, that too. But I think he's talking about people that have already gotten their food. Like they hop the line to get their food. And then they yeah. So guys, realize your peers pay more attention than you might realize. You're just still at the age where they may or may not call you out on stuff. But then as you start to get called out on stuff, what tends to happen is people get upset because they don't like getting called out. So always come to a teacher in that moment, right? Like Mr. Combs and Mr. Allen, those guys are out there. If you see that happen, go tell them. And they'll probably just go tell that student, hey, you're going to math lunch. That's what you said. And guys, again, it's not a punishment. I can't make anybody come, really. I just advise people, hey, you probably should. It's just time to get work done. I have people that are now asking, can I come every day even if I'm caught up? They're like, do I have to be behind to come to math lunch? I'm like, if this helps you get your work done, come. It's fun. I put on gentle music.
I love it. It's during lunch.
Come on, I got the cafe lighting.
Yeah, he's got the cafe lighting. It's so amazing. Do you have to do math in math lunch?
Yes! It's called math lunch! Now, if you don't have any homework to do, and you'd like to do math at lunch, would you like to jump in?
Math counts.
And to say those details again?
Stand up.
When and what and where?
Wednesday and Friday lunch now.
Where? Wait, really?
In Golders.
Yes,
Yes, it's in Golders.
It's today.
Yeah, it's today. We start today.
You know what
So we should probably talk before you guys start today.
Probably a good idea.
All right, questions on 522.
Where you get to pretend to know people.
Okay.
Could I bring my brother, who's a math major, could I bring his math book? And we could all try to work it out.
Sure, but we could also just do math counts problems because I bet you they're about as challenging. But you should have the knowledge base. Hey, Gus, stop. I was hoping one of your classmates would call you out, but knock it off, man. So math counts questions go up into high school level ability. So some of them you can't really solve yet, but a lot of them are manageable with what you have learned so far, and potentially a little bit of wait, what is this formula, right? If I need a formula for this, and then there's a reference page. The math counts book has a reference page. Yes, Brenda, because your hand is up.
Okay, so 540.
540. Any questions on the front? Let's start there for those equations. What they start with and what they're charging is how we get these equations. And then we could either graph it. Well, we're supposed to graph them, but we could also use equal values method. Guys, somebody after class came and double checked with me, and I think because we were having such a good time with Chubby Bunny Kitty method, the reason equal values, what we nicknamed Chubby Bunny Kitty method, works is they're both equal to the same thing. So in Chubby Bunny Kitty method, what we said was their weights were going to be equal, right? What we want here in the club problem is when will their clubs have the same amount of money, right? So in 6 weeks, $80. Any questions on that? I might have to just make a separate video, right? Like just a one-off short little video. 37. Yes, 80 is dollars. 37. Any questions? If you are copying answers, you better be ready to have a check minus because A needs to have work shown. Says that is what is the sum of the areas of the no, well. Okay, fine. I'm hoping somebody might call on me, but guys, okay, I take it back. A doesn't have to have work, but I will show you what work you'll be expected to do in your next math class. This is x plus 3. This is x plus 2. So if you really want to get a jump start on where you're headed in the next math classes, and I'm doing it for you right now, that is how we would write out finding the area. But then it asks for what is the sum of everything, and like y'all just yelled at me, yes, we can just write out it's x squared, 5x's, and then 6. This is actually a quadratic formula. Whoa, whoa, calm your jets. Which is what my, guys, here. This week is already kind of messed up anyways. Check it. It's easier for me to just go show what we were looking at in my class yesterday because I showed so many things.
I was trying to find YouTube, and instead I found your YouTube.
So if we haven't talked about the Desmos Art Contest, I think we did, but it's for ages 13 and up. But guys, what we're doing in my other math class, my 8th graders that I teach, all of this stuff that I'm teaching you right now, that we're slowly building up layers and layers and layers, you eventually can take it, and I wish I had them share their things with me, because my students made some really cool ones. This, and it looks like it bounces. It's real fun. That class kind of freaked out. Yeah, because then we did really cool stuff with it. High school math, too. All right, so all of that to say, this is where we're leading you with these questions right now. Please actually care about them. You don't have to have this form written down, but it'll help you if you go ahead and start like seeing that every now and then. So then the perimeter, if this side is also x plus 3 and this side is also x plus 2, then the perimeter comes out to simplify to what, 4x? Yep, 4x and 10. Maddie.
I have a question about when people do like 2 math classes in 1 year.
The only ways to do that are the compressed class that puts together 7 and 8, which actually this is the last year that we're teaching that, or there's a summer math course offering through Worthington Summer School. Go to Worthington's website, click on academics, click on summer school, or come talk to me later, but we can't talk about it right now. Yeah, it's just too many questions, too many things. Kids, really, if you're interested, talk to your parents and then have them email me. Brenda.
Okay. So 540.
We're getting to the back. I just flipped my paper. Okay, 540.
540. I need help.
Good, because these are the questions that kids are trying to tell me they were able to get the answer with no work, and I call malarkey. Actually, I'd probably more so call shenanigans.
I need to get
540.
540. is Fraction Busters. I know, but we're going to start with A because it's better to start with tier 1 and then get up to tier 2 or tier 3.
I'm confused by A because when you divide 10 by 7, it's like 1.0.
Divide 10 by 7.
Yeah, that's what I
You're
did.
way confused, so let's back this up.
What? That's what I did as well then.
No, I did 12.
I just did 10 7 divided by 2.
Yeah.
And then 10 divided by 5. And then 7.
Oh, I don't care. This is actually positive. I just wish you guys would do this stuff outside of class. Guys, do your homework together. These conversations you're having, you don't need me. What? Whatever. Forget Zoom. I don't want to Zoom ever again, ever.
Yeah, I hate
If. Hey guys, I'm going to walk through the why we do this again. Because really, like, before Thanksgiving break is a good time for us to make sure that, like, everything is, like, good, right? That we're, like, ready to move on. If I were adding fractions, what would I need? Does anyone? Common denominators. So I would multiply by 5 over 5 over here and get 5x over 10. I would multiply by 2 over 2 over here and get 2x over 10. Over here, nothing has to happen yet because I multiplied by 1 and multiplied by 1.
So 1, 1.
So now, if I really wanted to be able to compare all these things together, I could either add these up. Well, I'm going to go ahead and add these up because that's why I got the common denominators. But if 7x over 10 equals 1, that 1 is over 1. And I could actually put it over 10 if I multiply on top and bottom, right? Because 10 over 10 is equal to 1. If I did this, how could I destroy both of these denominators? Multiply the entire thing by 10. So on this side, I multiply by 10. On this side, I multiply by 10. That wipes out the denominators. And we get 7x is equal to 10. Hold. I'm going to do this a couple ways. Hold. So then, we divide by 7 to isolate the x. The other way that we can do this, just hang on to it. Because, guys, when your hands are up, you're not listening. Like, I'll take questions in a second, but I've got more math to show you. The other way that especially CPM encourages us to do it is kind of the shortcut. It says, if we think about this denominator being the denominator, and we know that eventually we would multiply to get rid of it, what they tell us to do, and I'm going to rewrite all of the work, like starting from the beginning. They say, think of your common denominator, right? This is our fraction busters method. Multiply by what that common denominator would be, but we have to do it on both sides. If I show my work, this becomes 10x over 2 and 10x over 5 and 10. This is 5x, this is 2x, and this is 10. We then get 7x equals 10. We still got to Florida, even though we took a different route.
Then I just divided by 7.
And then you divide by 7.
This route has less fractions.
But 10 over 7 is better than the decimal approximation of 1.4257. Dang it. 1.428571. Hi, did it. Connor. 10 years of teaching this. Sorry, you're staying. Nevin's hand is what I saw. Nevin. Good, because there's a bajillion ways to do it. Did you still get to the same answer? Awesome. I would love to show it, but we just are kind of running out of time today. Max. Do be. By the way, when you guys like do stuff like that, I kind of like think in my head, like, man, what if I had become one of those like YouTube people where like people tweet or whatever, and they're like, hey, do reseed. Have you guys seen the like the smashing thing where they smash candy or smash toys, and people like submit like, do this, do that. I feel like that's like us at this point in the year, and I wonder if we need like a submission sort of process of like, hey, do this question. I know the answer to this. I was gonna ask, would we ask more questions if we could do it anonymously? Do you think, or do you guys just not even really care? I hope that we feel like this is just a safe environment to ask and make mistakes. Common denominator would be 12. Everybody should do this with me because a bunch of us are still messing up distributive property, but we don't have to have that mastered yet, but we're gonna need to. So watch, both sides are gonna multiply by 12, but that 12 comes here and there and there and there. It goes everywhere. But watch, this becomes 12x over 3. But guys, the 12 needs to multiply by the x and the negative 1. So this fraction is really doing 12 times x minus 1, which is really going to make 12x and negative 12. But we're still over 4. So I'm going to highlight it to make sure that we're clear on what just happened. The 12 multiplied by x minus 1. But it multiplies by both pieces, making 12x and negative 12. Both are over 4. Because that fraction was over 4. Questions on the left side. It's okay if you did it wrong as long as we're figuring it out now. Brenda? Well, we're not ready for that. You're not asking about the left side. You're asking about the answer. 12 times 2, 24. 12 times x, 12x. Now simplify these things, which if we did fraction busters right, they should simplify. So 4x, both pieces divide. 12x divided by 4. Negative 12 divided by 4. Which side should be my variable side? Right here, if you want to keep things positive. But guys, there are like many options of how to solve. So I'm going to go ahead and put those together first. And then what do? Minus 7x would be my advice to you. It's not like right versus wrong. It's the most positive. Right? It keeps the variable positive. I was tutoring last night and I said easy and then I was like, oh, bad word. And the student looked at me just very confused. And I was like, oh, easy's a bad word here. Because like we were here tutoring and they're like, what? And I was like, I've made easy a bad word. I've brainwashed all my students. And I had to explain it to her. It was a funny moment. Yeah, but then I think I might get in trouble when people are like, this teacher's taking children's money when they say the word easy. But then, what if that jar like bought the prize for the homework class or whatever? Like, you know. Okay, I'm totally joking just to say it in this recorded format. I'm joking. I do not want your money. I do want your cookies though. I will say I had a cookie this morning and that was the best way to start my day. So guys, this, hey, hold up, let me wrap this up. This, hey, let me wrap this up real quick. This is gross. Well, it's not terrible when we go to do the division, but the better answer is just negative 27 over 5. Unless somebody says, hey, make it a decimal, this is just as good as anything else. The improper fraction. Now, they probably gave the answer as a decimal, just, no, see? Yeah, I win.
I realized that after
So fractions are just picked over.
Fractions. So here's the deal. Fractions are better because some decimals are just approximations. Fractions are always more precise. Fractions are always as precise as we can be, I should say. Decimals often need to round.
39. How do you get
Susan and her friends ordered 4 dim sum lunch specials.
Friends, 4 in total.
4 total. They ordered 4.
Unless they like food.
Make sure you pay attention to the fact that, man, this is going to make me hungry. 2 dumplings, 3 egg rolls, and a sweet bun. My wife says the best dim sum she's ever had was in New York City. And a drink. It was off the screen. I really want some dim sum now. All right, we ready to move on? Yeah, hey, guess what? Today's lesson, class, whatever you want to call it, is just going to be you guys getting a head start on your homework. Yeah, if you want to staple 521, 522, that makes my life easier.
Wow, you're making this so not hard.
You guys did have to turn in 2 homeworks where the other class only had to turn in 1, so that's
almost
nice.
But 522 was extremely not moderately hard.
And then we only have class Monday, and actually I think we're going to take a mastery.
Oh, okay.
Yeah, but none of you have pencils. None of you have extra pencils.
I do.
Is it like, has math power?
Yes.
It's an element?
Yes, it's a power that you can.
Yeah, I'm gonna be here tomorrow.
Can I miss the best one? Okay. Everyone get a 524. Because people were up and turning in homework, and I definitely. Hey guys, what you're going to do for the next 5 minutes is what I want you guys doing at extensions and in the morning. And like, sure, but do you still need to?
Yeah.
Okay, that's fine.
Do we try to find 2
No, please don't, because then I just have to sort it. But hey, Colin just asked a really good question. Again, I just try to level with you guys. When you turn in homework I don't want yet, it just makes me take extra steps of sorting papers and putting them somewhere else. So can you just keep them in your binder till we go over them, until we say, hey, turn this in? It'll be Monday. Like, we'll turn in 523 on Monday, so like you only have to keep it for the weekend. 524, the one we're doing right now, I don't know if I'll make it due Monday. We'll probably turn it in Tuesday just to get it out of your possession and make life easier than it could be. Because then I can check, are we all up to date when we come back Thanksgiving, after Thanksgiving. So, for your homework tonight on 524, determine the coordinates of each point of intersection without graphing. Guys, at this point, you probably don't even want to graph because it takes longer. What could we use here since they're both equal to y? Chubby Bunny Kitty method. In 58, and actually, Jake, this is probably really good help for you as well. 58 is exactly like what we were doing on the last paper, saying solve for x, solve for w, solve for what. But because we are like normally doing that with the end goal of graphing it, all of these in 58 want it to be y equals mx plus b form. So isolate the y, right? Get the y by itself.
So y equals x
Yeah.
minus 3.
59? Let's go ahead and set up 59 together. Get you a head start. Mailboxes Plus versus United Packages. These are made up names to keep people from getting upset. So if Mailboxes Plus sends packages for $5.25 per ounce, what would be like our y-intercept here? Max? Yes. Hold on. You're trying too hard, actually. To send your package, it starts at $5. And then plus 25 cents per ounce. So there's a base fee, right? This is like you got to pay to play sort of thing. You got to pay just to like get a box and send your stuff. Then you pay per weight. So for mailboxes plus, the equation that we could write there, yeah, you could either write 5 plus 0.25, and we'll make X our ounces, but you got to pay for every ounce. So that's what happens multiple times. Or you could write it 0.25 X plus 5. So I'm going to write that one down here. So then chat with your group about then if we look at United Packaging, and they start their charging at $2 and then 35 cents per ounce. How do we write that out in equation form? And then when he realizes the cost would be the same either place, what could we use? Wow, it was only Connor. Connor, you should get like a piece. that one was Connor. All right, and on that Chubby Bunny Kitty Bombshell, it is just about time to head out. So you got like 1 minute left. But that's, yeah, you got like 1 minute left. That's it, guys. So you essentially get it over here. Yeah, you times everything by 4 because they get 4 of each part of the order. So you make up your own variables. Hey, yo, back on 39, which I know some of us already turned in, the part I'm kind of looking for, hey, real quick. Part I'm kind of looking for is, do you choose a different variable for dumpling versus drink? Because we can't use the same variable, right? So you couldn't use D for both of them. So if you do D and like R for egg rolls and like B for sweet bun, then like, yeah, you got to pick something else. So maybe like S for soda or whatever, but you got to have different variables. Get out of here. Have a great weekend. That's it. We multiply each of the... So, be careful because it was 2 dumplings in one order, 3 egg rolls. You got to multiply each of those by 4. It's distributive property. Yep. It's distributing the multiplication.